Alright, so this one is focused on rationalizing. And the idea of rationalizing is the process of changing a radical denominator or numerator, mostly denominator, into an integer without changing the value of a fraction. Just like we had rules about no negative exponents, that solutions should be expressed with square roots, should not be expressed with square roots in the denominator. So we need to figure out how to get things out of the denominator. Now one thing to think about is if I had a fraction like 1/2 and I wanted to find an equivalent fraction, meaning something that's still equal to 1/2, I could multiply the top and bottom by the same number. And when I do that, it's still equivalent. Like if I put 3 and 3 here, I'm multiplying by 3 over 3, which is just 1. Anything times 1 is just the same as itself. But I get 3 over 6, so I know 3 over 6 is equivalent to 1/2. And this is the same process we're going to go through here, is to try to keep an equivalent fraction but get the square root out of the bottom. Another thing to think about is when you take the square root of 4 and you multiply it times the square root of 4, you end up with 4, right? Because you have square root of 4 squared, and the square and the square root invert each other, they negate each other, and you're just left with what is inside. So we need to do that to get rid of the square root of 2. And what we're going to do is we're going to multiply top and bottom by square root of 2 over square root of 2. And by doing that, I make the bottom square root of 2 squared, which is just 2, square root of 4, 2. And the top becomes 6 square root of 2, which I can now simplify the 6 and the 2 to just be 3 square root of 2. So this is now rationalized. Looking at the next one, I look at the denominator. I have square root of 5. So square root of 5, multiply top and bottom by square root of 5. Again, when I multiply by a fraction of the same number over itself, it's just multiplying by 1. I'm not changing the value. So this becomes 5 square root of 15 over 5, which the 5's divide out, and I just end up with square root of 15. Now notice there's no simplification to be done from there, but there might be. There might be. So I'm going to look at this next problem to see if maybe that's the case, or if I can simplify ahead of time. Square root of 15 over square root of 15, multiply that out, I get 2 square root of 45 over 15. And the square root of 45 can be simplified because it is just square root of 9, square root of 5 multiplied together. So that should give me 2 times 3, because square root of 9 is 3, square root of 5 over 15, which is just 6 root 5 over 15. But I'm still not done, because I can simplify. 3 goes into 6 and 15. So I end up with 3 goes in twice here and 5 times here, 2 root 5 over 5. Now, some people might either figure they stop right here. Others just start going crazy and they start simplifying everything. In fact, some people might try to simplify 5 and square root of 5. Well, those are different numbers. The square root of 5 is roughly 2.24. So you can't cancel 2.24 with 5 evenly. These do not divide in evenly. So this is just your solution. Now this next one, there's a couple strategies I could take. One thing to think about is, well, do I have to multiply bottom by 2 root 20 or just root 20? Well, the 2 is an integer. I don't need to worry about doubling it. I could do it, but then I'm going to be simplifying it out later. So let's do it that way, and then I'll show you a much more elegant way. So if I multiply the square root of 20 to top and bottom, I get 3 square root of 200 over 2 times 20. Square root of 200 is the same as square root of 2 times square root of 100, so this is 3 times 10 square root of 2 over 40, which is just 30 root 2 over 40. 10 goes into 30 and 40, so I get 3 square root of 2 over 4. Okay, so you could have taken that path and that would have been fine. But maybe another thing to think about is, maybe path B would be to see that you have you can pull a perfect square out of here, because this is root 4 times root 5. So this would be 3 root 10 over 2 times 2, because I pulled out the square root of 4, root 5, which is equal to 3 root 10 over 4 root 5. And now I just have to rationalize it. And the way I do that is multiply top and bottom by root 5 over root 5. And I continue 3 root 50 over 20. But again, I need to simplify root 50, which is just root 25 times root 2, all over 20. Continuing on, root 25 is 5. So I get 3 times 5 square root of 2 over 20. Simplified. 15 root 2 over 20, and yet I'm still not done. 5 goes into 15 and 20. 3 root 2 over 4 times. So again, I get to the same answer. So probably even less elegant. Even though it seemed like I was doing the right thing at the beginning, it made it even a little harder. Well, what about path C? Path C tells me that when I have the quotient of square roots, it's the same as the square root of quotients. So I could rewrite this as 3 over 2 times the square root of 10 over 20. And so what I do from that now is 10 over 20 is just 1/2. So that's the square root. So this is the same as 3 over 2 times square root of 1/2. And again, I wouldn't write all these steps out, but I just want to make it really clear. So the square root of 1 is just 1, right? So this is just 3 times the square root of 1, which is 1, over 2 root 2. And now I just have to rationalize this by multiplying top and bottom by root 2. This becomes root 2 times root 2 is 2, so 2 times 2 over 3 root 2, which is just the same thing as we got before. So multiple paths, if I would have jumped to, okay, this is just 1/2, and I know that square root of 1 is 1, so I would have just jumped right to here, which would have taken me fewer steps. Your call. Lots of ways to get there. Just make sure you know that you're getting there to the right solution, and you're simplifying enough. Adding these two, you need to get a common denominator, right? And the common denominator between root 3 and root 2 is just the product of the two, which is root 6. So I multiply top and bottom by root 2 and root 2 to get root 6 on the bottom on the left side, and by root 3 over root 3 to get root 6 on that side. So rewriting, I have root 12 over root 6 plus root 3 over root 6. So now I add these. Well, these don't look like I can add them, but I could simplify root 12 into square. Let's see, this is square root of 4, square root of 3 over square root of 6 plus square root of 3 over square root of 6. So that in fact can simplify, right? Because square root of 4 is the same as 2. So now I have 2 root 3 plus 3 root 3. Or sorry, 2 root 3 plus root 3 is just 3 square root of 3 over square root of 6. And now I have to simplify. The 3 and the 6 simplify to 1 and 2 because they're both in the square roots and there's no addition or subtraction going on up top or bottom. I can do that. So this is just 3 over the square root of 2, which rationalized is 3 root 2 over 2. The bonus, if anyone wants to discuss with me in our conferences, I'm happy to do so. It's a pretty interesting problem, but one thing to think about is you need to multiply it by something called the conjugate. So if you want to look that up, this will become very useful in Algebra 2 and even further in this course as well.